Hello and good evening, everybody. Yes,
Good evening, sir.
good evening, good evening,
Good evening, sir.
good evening, Samir.
Good evening, sir.
Good evening, Shaji.
Good evening,
Suleko.
sir.
Good evening,
Good
everybody.
evening, sir.
Yeah, everybody. Good evening. Let us start today's session. Now, today I am not going to discuss anything about column. Straight away, we'll go to our RCDC and we'll see how we can import the MDB file. Okay. So
Okay, sir.
yeah. So let me present first. So you will see the things. Okay. Now I am presenting to everybody. Please check whether you can see it or not. Okay. Yes.
Yes, sir.
Okay. Yeah. So straight away we'll go to our CDC. Now we don't have to go for again preparation of that MDB file because we have imported all data. Okay. So straight away we will open RCDC and we'll see that. Okay. Maybe batch 20 project say residential column design. We'll say that uh, column design. Column design. Then client you can say B20 maybe and engineer anybody you can say engineer me. So these information is very important. Otherwise, it will not uh, uh, go ahead. Okay. Then here you will provide the path. Now, where is the path that actually it is on computer e-test tutorial. Let me see that. So this was our file, right? So click on it. The path is given, and now instead of footing, now we'll go for column and wall and create. Now the file that was earlier was for footing, so here we have to go for create new project. So this will be a file for design of column. So now it will start reading the information that has been given in that MDB file, and you can see it is yeah. So it is starting reading the things, and everything will be read by them. And after that, all information, that input information with analysis, and now you can see the columns and walls. Okay, clear? Hello.
Yes, sir.
Yes, sir.
Now you can shift to this, but before that you can go to settings. Now, in the previous file, all settings were with respect to uh, isolated footing. So whatever are the codal provisions and input required for detailing, that was asked by him. Now he will ask for settings in columns. So you can go for design setting. Now this design sheeting, here you can go ahead and you can see ductile design. Okay, so consider beams here. Then if you want to go for live load reduction, right?
Yes, sir.
So how many of you know live load reduction? Hello, anybody who knows
No,
something?
sir. No, sir.
No live load reduction.
सर फुटिंग में तो 40%
सर
किया
वो
था.
नंबर ऑफ फ्लोर्स के हिसाब से था सर वो।
Right. Yes, you're correct, Samir, and we'll see that. Okay, Samir knows it clearly, but for others, I will just explain the things. It's quite simple. Now, this live load reduction is not as per our that seismic. So, whatever live load reduction that you have considered in calculation of base shear, that is different. Don't get confused with that 0.25% of live load when live load intensity is less than 3 and 50% when it is more than 3. Right? That was used in 1893 and that is for calculation of seismic weight. Clear?
Yes, sir.
बहुत सारे लोगों को इसका और उसका प्रॉब्लम हो जाता है. Now this is a reduction for design of column. Let's say this is your footing. Okay, so this is your footing and you are having one slab, two slab, three slab, four slab, five slab, 6 and 7. Okay. Now if you are designing a column of this floor level, okay, which is just below the roof, and at roof you are considering live load intensity as 2 kilonewton per square meter. That has been given by you in the analysis. Clear? Hello.
Yes, sir.
So apart from this live load, there will be dead load on the slab. There will be uh, walls on the beam and self weight of slab and beam, etc. All that is going to be supported by this column level, right? Yes.
Yes, sir.
So in this case, I will say that this column is supporting only one slab. So in this case, live load reduction will be 0. क्योंकि I cannot go for economy. But now let us say I am designing this column or the columns of this floor. Yes, all columns. Huh? I'm not talking about one column. I'm saying all columns which are supporting two slab. How many slabs this column has to support?
2 slab.
1 and 2. Right? Hello.
Yes sir.
Now here also you are having 2 kilonewton per square meter or whatever is there. Now again this input already you have given in analysis. Now this slab will transfer the load on this column and the column above will also transfer a load on this column. So this column has to support this slab as well as this column.
Yes, sir.
Yes. So how much live load this column has to support? 2 plus 2.
4.
Now here code says that for design you can reduce the loading or the reaction that has been calculated by the analysis. So live load reduction will be up to 10%. Clear? Yes.
Yes sir.
For each floor, sir.
Because yes. Hello.
Yes sir.
Now you can see this column or the column in this floor. See, thought process in this is that there are lesser chances of both the slabs will be subjected to high level or maximum level of live load simultaneously. Chances, there are chances, definitely there are chances. That's why only 10% is reduced, so that this column will be designed for economy. So I will get optimum design for this column. Clear? Now consider this column. Now this column is to be supported by this slab. This column needs to support this slab as well as two columns above. And then again there will be additional 2 kilonewton. So here additional 10%. So total reduction will be allowed by our code as 20%. So 10 over here, and that means 20% of the total. Then here you can say similar, here you can go for 30%. Here you can go for
Okay.
40%. And finally here it says that you can
50%.
you can go for say 40% now. Now no reduction. Okay. So 40% reduction in the live load is accepted by our code. Okay. Hello.
Yes, sir.
Now this condition we have not given as input in our analysis. In analysis, entire slab will be subjected to live load. That live load is transferred through beams on the columns supporting the slab everywhere. So that's why only there will be a reduction in live load. This you will find criteria. Now that criteria we are going to set over here in the settings. Clear?
Yes, sir.
So if you want ductile design, you can go for, or you can right now you okay. We'll go for ductile design, live load deduction. And if you want to see that, you can click on edit, and you can see that. So for first number of levels supported 1, reduction will be 0. Number of levels supported 2, 10, 3, 20, 4, 30, 5, 40, 6, 40, 7, 40, 8, 40. Clear हो रहा है?
Yes, sir.
So only 40% reduction is accepted up to 10 number of slabs. After that, code says that okay, again you can go for additional 10%, but maximum 50%. So below floors will be designed for 50% of live load, and that is why I have not given you this, because you might have not understood this, or if you understand this, you might have confused this clause with that clause of reduction that has been used in 1893. So that reduction for live load in analysis, that too for earthquake analysis, that is for calculation of seismic weight, and based on that we are finally calculating base shear. So that is the analysis part. And here in design part, whatever loads are there up to that level, they are automatically reduced if you apply this. So if you do not apply, then he will not consider a reduction. Clear?
Yes, sir.
Hello. Now, many times columns may not be braced. Uh, you know how the columns are braced? Anybody? Hello. See, these are
With
the
integrating beams.
yeah. Only see, you can see the columns are breast. Let's say this is a column. Now, if this column is having a beam on this side, a beam on this side, then you can say that it is breast for this axis 3 3, and this beam for axis 2 2. But many times what you get is something different. So many times you are having a column and you are having beam on this side, a beam on this side, but there is no beam on this side or on this side. So this column is breast only about axis, major axis, but for minor axis it is not breast.
इसमें
Okay,
क्या मतलब इसका मतलब क्या
आया है ना
clear हो रहा है?
Yes, sir.
Now if you do not include this as a breast, then if in your drawing, if there are no beams at that floor level, maybe for any architectural reason, or yeah, that beam you might look from below. So in that case, only the slab will be the column will be braced with slab, but depth of slab is hardly 150 max in residential buildings, and that is not sufficient. So in design it is considered unbraced, and that is based on your uh, whatever model that you have developed. So if you see that you don't have a beam over here or somewhere, 1 minute. Hello. Uh, so 2021 बैच में एक मिनट। नहीं, एक काम करता हूँ, अभी यहाँ से तो मुझे कनेक्ट नहीं करने मिलता, बट सी व्हाट वी विल डू, विल ट्राई टू गिव यू द रिकॉर्डेड सेशंस, और नेक्स्ट टाइम मैं इस बैच की भी आपको मेल भेज देने को बोलता हूँ, वो लिंक। अच्छा, हाँ, 1 मिनट, मैं कॉल करके देखता हूँ, सिर्फ 2 मिनट। ओके ओके। One of our colleagues wanted to attend it, but actually I don't have that control. So okay, let me see whether he has joined. Yes. No, he has not joined. Okay, that's okay. Okay, so you can see over here, many times what happens that there may not be, let's say you are having a column over here, and in that case you may not have a beam like this. So in that case, that column is considered as unbraced, and that means L effective goes on increasing and column becomes long. And if you do not want that to happen, then what you can do, you can consider this as a breast. Okay, so forcefully you are making assumption, and you are telling to this RCDC software that don't go through that model whatever I have been created. Just consider this column as a breast, even if it is not breast. Clear?
Clear, sir.
Yeah. Now, if I don't click on this and the column is not braced in that direction, then it might get subjected to additional low bending moment, and because of that the column may you may get higher reinforcement, or sometimes the RCDC may ask you that change the sizing so that it can allow a reinforcement. So in that's why it's better. But uh, why it is to be clicked, that is what I am trying to explain. Clear?
Yes,
Now,
sir.
yeah, now this ignore intermediate beam for merge levels. So you can just ignore that. Don't worry about it. Then you can see optimize design. You can ask him to design it optimize. So he will consider all. He will follow all codal provisions of IS 456 and 13920, because we are going for ductile detailing and live load reduction. And then consider slenderness effect. That means whether minimum eccentricity is to be considered slender, uh, even if L effective by 12 is greater than 12, then that slenderness, due to that slenderness, the capacity of column is reduced by calculation of that lambda factor. So that you can say yes. Then resultant moment, combined action. So design method is resultant moment, that is for combined action, that is PU and MU. Then interaction principles, discrete action. So you can go for this only. Then shear wall settings. Now, when shear wall, see here, whatever sizing of the columns that you are providing, if the D by B ratio is more than or equal to 4, then it will consider all shear wall calculations. Okay. And ductile wall with boundary elements. Uh, Again, I will have to talk about this boundary element when we'll be going for design of shear walls. Right now we can say that boundary element. Okay, anybody having any idea about boundary element? Hello,
No, sir.
idea है कि नहीं है?
No, sir.
See, if you are having a shear wall, something like this. So this may be, let's say, 2000. So the length, or you can say depth of the column, and this may be say 250, or let's say 300. So now you can see 2000 divided by 300 will be definitely more than 4. So I am not going to calculate. So he will consider this vertical element as shear wall, and he will apply all codal provision regarding shear wall. Now, in the shear wall, many times uh, the boundary elements are considered at the edges. So let's say this will be one element, and this will be another element. Okay, and this will be middle part. So entire shear wall is considered in one, then this two, and these three parts. So two parts these two parts will be braced by this middle part, and you can see that this will act as a column, this will act as a column, and it will be braced throughout the length of the column by this middle part. So this is called boundary element, and many times you may find boundary element something like this. That depends on what type of loading that you are going to resist through shear wall. But normally, this type of shear wall construction is avoided, and the width of the column is considered as 300, and this D will be depending on this, and it may be something around uh, 2 times 3 times B, or
900
maybe
mm.
yes. So
3
this
times V 900 mm, sir.
this is 300, then this could be 900. So 300 by 900 on this part, 300 by 900 on this part, and remaining part will be considered as this middle part. Okay, so this is called a boundary element, and he is asking you whether you want to be considered ductile wall with boundary elements. You can say yes. So he will take care of all the calculation of boundary, what should be the D, B is defined, what should be the D, and what should be the middle part. So that can be taken care by this software. Clear?
Clear, sir.
Now you can see minimum eccentricity. So uh, one axis. Now, minimum eccentricity is always considered with one axis at a time. So you're not going to define it with Y, and Ex simultaneously. So that's why most of the time one axis at a time is highlighted, and you can ignore check if you do not want to check the minimum eccentricity. But normally you can say that this is to be highlighted. Okay.
Okay, sir.
Then this is about crack width. Again, this crack width calculation is carried only for water retaining structure. And now we in this we can clearly uh, uh, we can say that we don't need this. Otherwise, if you click on this, he will ask you which code you can use. So IS 456 or IRS. So these are the two codes that we are using for perform check for crack width. And if it is unticked, then it is not applied. Clear?
Yes, sir.
Then material properties, uh, you can add it. Uh, the material properties from the analysis. You can say that use the material properties whatever I have given in analysis file. So this is all about design setting. Clear?
Yes, sir.
Now about reinforcement setting. Now again you can see what is the minimum percentage that you want. So as per our code, it is 0.8. So I will say that I need minimum percent in column as 1, and maximum as per our codal provision is 4. But I will say that no, I'm not going to use maximum as 4. So I will stick up with say 2.5. So that is up to your choice. So as per our code, what is the minimum that we should
0.08.
provide? 0.8. And what is the maximum that we should provide? 6%. And advised is 4%. But
Please put the
you can have your control on the size of column. Based on that, he will give you the reinforcement. Then shear wall percentage. So you can use this 0.25, and maximum you can say 4, because whatever is required only will be used. So again, I will say that if you want to understand this, you will have to use uh, all the codal provision that are defined by our code, that is for shear wall. Then you have to read that. I will say that 25% you can apply for when it is a shear wall. You can say 25% is minimum and 4% maximum. Then longitudinal rebar spacing. Uh, Again, this is as per our code, but I will say I don't want anything less than 125, and maximum I don't want anything more than 200. Okay. Then preferred preferred rebar spacing. So equispace 125, zone number 1. You can see value beyond permissible range specified. So you will have to go for say 75.
तो ये जोन 1 क्या
25. Actually, why it is saying that you can check it over here, 100. So it shall not be for this zone 1 and zone 2. What are the zone 1 and zone 2? Hello? Yes, anybody?
Reinforcement near junction of beam.
Yes.
Zone 1.
Okay. Let me tell you that quickly so that nobody will be lagging behind. See, this is your column. This is your floor, and this is your bottom of the beam. So in that case, see, this is one zone. This is another zone. So this is zone number 1. This is zone number 2, and this is a middle zone. So you can say zone number 3 or mid zone. So it is L by 4. This is also L by 4, and this is L by 2. Clear? Where L is the length, which is this. Yes, clear, Abhi?
Yes, sir.
That's why
Yes,
it is
sir.
called mid zone. See, understanding RCDC is very simple, provided you know the codal provisions. And if you don't know, just go through this and read the code as per these information. So longitudinal rebar spacing. Then go and see into the code what is the codal provision given for longitudinal bars. How much should be the minimum? How much should be the maximum? As per code, it's not as per design. सो डिजाइन से तो जो आपका फोर्सेस है वो फोर्सेस के हिसाब से जो आपके साइजेस है उसके हिसाब से वो आएगा बट मान लो व्हाट विल हैपन इफ you are getting longitudinal rebar spacing that you are getting through your design as say 50, then that is not allowed by code says that minimum shall not be less than 100
Mm.
and maximum shall not be more than 200. That is what I am saying over here. But you can check codal provision. Code says that 75 and to 250
Okay.
or 300. There are clauses with respect to width of the beam and with respect to bar diameter that you are using for longitudinal reinforcement and bar diameter that you are using for lateral ties. So there are various, you can read that. That is not much big thing. And then you can see it. We are not going to use 10 or okay, that might be required for that. Okay, 8, 10, then 12, for 16. These are typically, or you can say this also, because normally it will be used in shear walls. 10 diabar is used in shear wall. 8 diabar is used for lateral ties, and all other bars you may need as per your analysis. Okay, so then you can see column rebar minimum shall be 12 and maximum you can put it over here. You may not be interested in using bar more than 20. You can say 20. So based on that, he will calculate the number of bars and like that. Then shear wall minimum, you can say minimum I want to use as a 10 and maximum I want to use as say 25. Then links minimum bar 8 dia, then bundle bars, and then these are the links. What type of links you need? Do you want this lateral ties or hoops? So normally this hoops is used, then hoops for wall and tight style will be closed. Okay, so you can use this. Then this main link with boundary element. You can see the sketch of boundary element. Yes,
Yes,
either you
sir.
can go for this or you can go for this. So probably I will go always with this, but there are competitors in market, and for want of economy, they are providing bars like this, but which I don't like. But see, as per code, you should use this. Then round of factor, you can choose 25, 25, and then click OK. Yes,
Yes, sir.
clear हो रहा है?
Yes, sir.
Sir.
Then reinforce हो गया, detailing and drawings settings. This is for your drawing requirement. So what type of detailing in the drawing you need? So for drawing, provide first slab below plinth. Display material properties, you don't need. uh, Display lab dimensions. If you want this, you can click on that. And if you want to display lab dimensions, then he will ask you whether you want in fixed text or uh, only the lab dimension. Then provide continuous section numbers. So show lab and at each level. If you want a lab at each level, you can say so, or you can delete it. Then reinforcement level, क्या आपको rebar का use rebar or use rebar reference tags or both. So you can choose anything of this as per your choice. Then level for elevation, use level description as this, or you can use a reduced level. So if you click on this, then he will ask what reduce level, or you may uncheck and he will go with preference PL, or you can say anything into this. Whatever is your input, that will be up to that. So we have done it up to overhead water tank and lift. So normally PL. Then laps and splices, whether you want rebar splicing or whether you want mechanical coupler. I think many of you may be knowing this mechanical coupler. Yes, hello.
तो उसमें विदाउट वेल्ड हम डायरेक्ट उससे कंपोनेंट से कनेक्ट कर सकते हैं.
See, normally this is your bar. Okay, and you have to lap with the bar below. So you can say that the lapping is done. Most of the time, the lapping is prepared something like this.
Yes, sir.
Clear? And this is your lap splice, so which is LD. Yes.
Yes, sir.
Now consider if you are having this bar at 32 dia. This is also 32 dia. What will happen in this part? There will be double the bars. Yes. And what will be the lap length? 50 into 32,
Yes, sir.
right? Something
Right, sir.
around
Yes, sir.
1.5 meters. Yes.
Yes, sir.
So are you going to provide that? So in that case, nowadays, what is considered, this is the bar. Okay, so this is the bar, and this is your bar below. Okay, and these two bars are, instead of lapping, they are provided with couplers. So these couplers are having some something circular, let's say tubular. So this inside diameter is the diameter of this bar, and it is on the inside, it is with threaded. So on this part and on this part, so these two bars get threaded inside, and this coupler. Now these are the mechanical couplers, just like uh, you're having two GI pipes with coupling.
Yes, sir.
Now this is asking whether you want this type or whether you want this type. That's all. I'm just explaining you because normally people do not have that understanding कि ये है क्या mechanical coupler. It is recent. See, many times in earlier what we used to design 3-story, 4-story, or maximum 5-story structures, and in that case, most of the time we were using the bars below 16 dia, so they can be easily lapped. But if you are going for high-rise structures, that to 20-story or 30-story or 40-story, so at the base level, you might need the bars of 32 dia or 25 dia, and there may be 50 bars of 32 dia, or maybe 25 bars of uh, 25 dia. So if you go for lapping, then there will be 50 number of bars of 25 dia, and that section might get congested, and the costing of the lap is more. So you need 1.5 meter or at least 1 meter development length. So to avoid that, these mechanical couplers are developed in recent, so maybe something around 10 years back. So mechanical couplers, just like you are having uh, joint of the pipe, GI pipe. Are you getting it?
Yes, sir.
So that type of couplers are nowadays available, and the cost of that mechanical coupler is less than that 1.5 meter dia bar. But if you are comparing that with 16 dia or 12 dia bar, then that coupler cost will be more. But if you are using going for 32 or 25 or anything more than 20 dia, then that coupler cost is less than the lap length bar, and that's why it is used. And basically, not for only economic, basically it is giving you conjection free lap. Clear?
Yes, sir.
Yes. So either you can choose this or you can go for this. Then location. Now this is at mid height or at top of slab. Normally at mid height. N- Initially, the lab was provided at top of the slab, but now this practice has removed from the textbook or from code. Now code says that you have to make the lapping at the mid height. And can anybody let me know the reason for that? Yes. See, this is my column. A slab over here, a slab over here, and if this column is subjected to lateral loads and it is to resist the lateral loads also, then if I see my bending moment diagram, uh, I will get a bending moment diagram, either something like this. Yes, or you may get a bending moment diagram something like this. So let us say this is mid height. So at mid height, bending moment is 0. At here or here, the bending moment is maximum. So if I am going to have a lapping in this zone, that means I am lapping the bars where they must have a full strength. But if I am lapping in this zone, then you will see that the bending moment that is to be registered in this section is lesser. Yes.
Yes, sir.
So this is the reason that lap location is at mid height. You can go and see the 13920. You will find the lapping requirements that are given by the code as for your guideline. Okay. Okay. Then style. Again, style will be staggered. Okay. Not at so all the laps will not be at one level. They will be staggered. So at least 50% will be at one level and 50% will be at another level. And you can uh, rebar mark manager foundation data. So I don't know this. Why? Okay, you can skip that. Click OK. Then zone bar setting, not required. Okay, now basic load cases. You can go for basic load cases, or you can say import load cases and combinations from analysis. Okay, not from this. So we'll say that uh, we'll go for this as dead, this as our earthquake, this as earthquake Y, this as live load, this again as you can say earthquake, or you okay, oh, you can go for that earthquake in Y direction, and this as again a dead load. So highlight all, put it on this, and you can click OK. Now combinations, you can say no, actually view, edit, add from analysis. You have to go and say yes. So add from analysis. So you can check it. So these dead wall 1, D wall 2, etc. These are all that are by ETAB. So these are the analysis load cases design. Okay, and you can keep it as it is. So settings, load combination, you can see it has been added. And then you can go for design. Auto design. See, everything will be now. See, this is the only important thing that you have to do when you are going through RCDC, because rest of the calculations and reports, etc., will be generated by RCDC, and that's why this software is most popular in private big firms, because they get the data, they can do it again within no time. Manually thoda karna, it's a time conversion. You can see he has started designing columns. and all columns at all floor levels will be designed, detailed, and AutoCAD reference drawings will be given for you that you can convert in your company rules and regulations or company format. So only if this much is prepared by you, you have to carry out only the find out only the analysis uh, by any software, maybe STAD or ETAP, and rest of the things design will be considered by RCDC within no time. Actually, I am explaining you each and every aspect, and that's why we are going through so much time. Otherwise, this process is just a process of 5 to 10 minutes. Do you agree? Hello.
Yes, sir.
And that too, I want you to go through all basics. That's why I'm taking that much time. Otherwise, one can say that you just go to settings and use all settings as per your codal provision or as per your choice, and the remaining things will be done by RCDC. It has actually some problem with this. I have to check it because it's taking a lot time. It does not take that much time for calculation. Within no time, it is giving the calculations. Rest of the things I think all of you know. Yes. Hello.
Yes, sir.
अगर अगर कोई डाउट है तो you can ask me the doubts because it's taking time. So instead of waiting for him to do the things, or might be actually the design process of designing columns process is going on, but why it is taking time, I don't know. Maybe some software problem. I just, and I cannot help anything into this. Okay, one more thing. Whenever you are designing this, that one clause we talked about live load reduction. Okay. Hello.
Yes, sir.
Yes,
Uh,
sir.
आपको क्या लगता है उसने लाइव लोड रिडक्शन लिया होगा?
लिया ही होगा सर.
ऐसा लगता है ना?
हाँ.
कितने लोगों को
Specify
ऐसा लगता है?
इससे सर आप वहाँ क्लिक किए स्पेसिफाई किए वो तो ना. अगर
किया
नहीं-
तो लेगा फिर.
Yes, but let me tell you that's why okay, we are having a time, that's why I'm explaining. See, ETAB says that, but I think that is in ETAB. If you are using ETAB for design, right now we are not using ETAB for design, we are using RCDC for design. So in this case, he will go through reduction of live load. But if you are going with design by ETAB itself, the requirement of ETAB is that if you want to have a reduction of the live load at the time of design as per your codal provision, then in the primary load cases, when you are defining the primary load case, you have to define it as reduce live load. That is basic clear thing that I am explaining. If you are defining that primary load case as a live load, then even if in ETAB you are asking him to go for reduce live load, he will not reduce because your live load defined in your definition is not reduce live load. You can check that. You can design it with ETAB, and you can see that it is not considering the live load reduction unless you define the live load as a reduced live load. Clear?
यस सर.
ये डाउट है?
नहीं सर, कोई डाउट नहीं है.
Many people do not know this. I don't know why. Because people say again the basic thing again the same is that if you have a practice of reading the help file of ETAB, then you will understand in the help file ETAB has clearly mentioned. But that clause will not be applied over here because you are using another software. You're not using ETAB. So even if you have considered here as a live load and you are using RCDC with that reduced live load, it will reduce the live load. But that confirmation myself, I don't have that confirmation because normally I don't use RCDC. तो आप लोग बोलेंगे सर हमें क्यों सिखा रहे हो, ऐसे है ना?
नो सर, हम सीखना चाहते हैं सर.
सीखना जरूरी है, but I will say that you can learn each and everything, but never believe the things unless they are justified, verified and tested. मैं ये नहीं कह रहा हूं कि उन लोगों ने आपको कुछ गलत दिया है या मैं आपको कुछ गलत सिखा रहा हूं. The thing is that there are some minor flaws which might be missed while training, like this reduced live load. Because when in many times in interviews when I ask the people that if I am asking ETAB to design with reduced live load, will it consider? वो बोलते हैं हाँ सर, नहीं करेगा unless you define the primary load case as reduced live load. He will not consider the live load reduction at the time of design. And again, don't get confused with that analysis part and design part. Yeah, it's taking too much time. Yes, anybody having any query? अभी भी शायद 5 मिनट तो लगेंगे उसे, ऐसा लग रहा है. ये जो स्पीड से जा रहा है अभी क्या है,
सर
बैलगाड़ी
आपने वो नहीं भेजा प्रैक्टिकल के लिए.
हाँ वही तो मैं सोच रहा था. नहीं अभी क्लास खत्म होते ही आपको भेज देता हूँ.
मेरे पास जितना था मैंने डाल दिया था ग्रुप में, 2 ही था मेरे पास.
नहीं दे देता हूँ, अभी भेज देता हूँ. मगर
एक्सक्यूज मी,
या यस समीर,
तो एक डाउट था सर उसमें.
पूछो
आपने सर
पूछो,
वो
एक नहीं 1000 पूछो.
हेल्प का सर वो एनालाइज मैनुअल था ना सर, वो आपने बताया था.
हाँ
उसमें सर एक चीज पूछनी थी कि दो चीजें थी सर उसमें. 1 जॉइंट लिंक सपोर्ट था और 2 जॉइंट लिंक सपोर्ट था. तो सर उसमें
अच्छा नहीं, वो थोड़ा एडवांस है, वो थोड़ा बाद में देख लेना. See, one joint link support means it is used as a support, because see, 2 joint link is considered in your entire frame, because that spring will have 2 joints, but when it will be considered at support, that means at foundation level, then
yes,
it will be connected to one joint only, and another joint is directly connected to your support level, that is
yes,
foundation. That is that one joint and 2 joint.
yes, sir.
ये
2
बढ़िया है, एटलीस्ट.
जॉइंट समझ में आ गया सर. 2 जॉइंट में थोड़ी कंफ्यूजन थी, अब वो क्लियर हो गई सर.
वो normally that is used as a advanced analysis, थोड़ा बाद में आएगा. But if you are going with non-linear analysis, only in that case you might need that.
तो स्टार्टिंग में दे रखा था जब पढ़ रहा था ना, तो बस बाकी सब समझ आ गया था. ये नए टर्म्स लगे इसलिए पूछ रहा.
नहीं डेफिनेट है उसमें बहुत सारे नए टर्म्स हैं, constraint, restraint, and degree of freedom. तो कंस्ट्रेंट तो लोगों को समझ में आता है, रिस्ट्रेंट समझ में आता है, कंस्ट्रेंट नहीं समझ में आता। ये कंस्ट्रेंट क्या है?
अभी सर ये टाइप पावर क्लास होगा।
यस,
कंस्ट्रेंट तो सर उसमें वो होता है कि अगर जैसा आपने वो डायाफ्राम का एग्जांपल बताया था, उसमें
हाँ,
अगर
उस
सर
समय
एक
उस समय
साथ
मैंने
अगर
बताया।
रिएक्शन आते हैं तब वो कंस्ट्रेंट होता है।
नहीं नहीं, मगर ऐसे ऐसे टर्म्स है उसमें,
यस सर, उसमें है
बहुत
सर।
सारे बहुत सारे बहुत
सर
सारे नए टर्म्स है।
डिफरेंस क्लियर हुआ था सर मेरे।
या मगर जितनी बार रीड करोगे ना तो धीरे धीरे समझ में आने लगेगा। सी सी द वे, मैंने ऐसे ही समझा, मुझे किसी ने बताया नहीं। और मैं जब किसी को पूछने जाता था तो वो बोलते थे, अरे क्या पागल है, खुद भी पागल है, हमें भी पागल बना रहा है, और जाओ ना बाबा, दूसरा धंधा नहीं है क्या?
धीरे धीरे आ जाता है सर,
हाँ,
सब धीरे धीरे सब आ जाता है, कोई बताए चाहे मत बताए, थोड़ा लेट से जानेंगे और क्या।
लेट लेट होता है,
चीजें
आ
क्लियर हो
जाता
गई थी,
है।
दो बार पढ़ा तब जाके क्लियर हुआ।
यस यस यस, मैं देखो, यू आर वेरी फॉर्चुनेट, क्योंकि आपको 2 बार रीड करना पड़ा। मैंने कम से कम 8-10 बार रीड किया, फिर उसको राइट डाउन किया। मैं बोला नहीं, अभी लिख के निकालता हूँ, सब जैसे है वैसे ही कॉपी करता हूँ ऑन द नोटबुक। तब जाके एक एक चीज समझ, अरे हाँ शायद ये हो सकता है, ये हो सकता है, और फिर दोबारा रीड करने के बाद आ जाता है। सो दैट एक्चुअली दैट्स, बट मैं ये कहूंगा कि when you start reading you might not follow what he wants to say, but through that process you will sharpen your engineering understanding.
यस सर।
सर यहाँ ही सीख लेंगे तो सर जहाँ कंपनी में काम करेंगे वो क्या सिखाएगा?
या
सब यहाँ सीख लेंगे तो
हाँ,
फिर काम करते करते एक नॉलेज एक्सपीरियंस आएगा, जो हमारे सीनियर होंगे तो वो क्या बताएंगे फिर
तो
वो
आप उनके सीनियर हो जाएंगे ना।
नहीं सर, वो नहीं नहीं बताएंगे, फिर कहेंगे सारा काम तुम ही करो।
नहीं 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 नहीं, अरे बाबा, ऐसा नहीं होता है। जब जब कोई परफॉर्म करता है ना तो उसका प्रमोशन अपने आप हो जाता है।
मेरा एक इशू था सर, वो आपको बताए ही थे आज।
हाँ हाँ हाँ, दोपहर को आपने कॉल किया था।
हम्म,
अभी एक काम करता हूँ, मैं आपको मेल भेज दिया ना, तो उसी मेल एड्रेस पे मुझे वो मेल कर दो।
ठीक है
आई
सर।
विल गो थ्रू दैट एंड यस, देखो हो गया कॉलम फेल्योर। अब जहाँ जहाँ वो फेल हो गया है वो आपने उसने आपको दिया, ये देखो। अब ये जो रेड दिख रहा है ना, ये आपका फेल्योर है। यस,
यस सर।
सो बेस टू पीएल, देन पीएल टू फर्स्ट, ये फेल हुआ है। क्यों फेल हुआ है? 230/900 M25FE415 डिफाइंड एज कॉलम ई, कैपेसिटी रेशियो नॉट गिवन। तो आपको इसको रीडिजाइन करना पड़ेगा। सेक्शन को ओके, पहले तो क्या करते हैं, विल गो थ्रू दिस एंटायर प्रोसेस। यू कैन सी जितने जितने फेल हुए हैं ना
जी सर।
वो आपको मिलेंगे, और मोस्ट ऑफ द टाइम आप देख सकते हो कि जो आपका रीएनफोर्समेंट है ना, आपने उसको मैक्स, ये देखो यहाँ पे, और 16T20 विथ बेस टू पीएल। तो ये लोडिंग में कुछ गड़बड़ है, आपको वो देखना पड़ेगा। कैपेसिटी रेशियो एक्सियल इज दिस, flexure is this, and percentage. See here, you will see that percentage. So what you have to do? You can close this, uh, and you can go to settings, in design settings. Okay, reinforcement settings. Okay, will unlock. Okay, it's sign input. Okay, we'll see that why it is failing. Uh, Codal provisions. Failure does not mean that you're going wrong. It may be related to minimum and maximum codal provisions. See, as per any सॉफ्टवेयर वो बोलेगा ये कंडीशन फुलफिल नहीं करता है तो फेल हो गया. समझ में आया? हेलो. And these are again, these are walls. You can see these are walls. Okay, so these are walls. Then
फिर हम लोग शेरवाल में ये क्या बोलते हैं, लोड कम्बिनेशन नहीं ना लगाए थे? शेरवाल का लोड कम्बिनेशन नहीं अप्लाई किए थे हम लोग?
नहीं नहीं, वो जो अवेलेबल लोड केस है वो लिया उसने. वो शेयर वॉल का लोड कॉम्बिनेशन है ना, वो एट द टाइम ऑफ डिजाइन ही देते हैं. तो
हम लोग नहीं दिए थे.
यहाँ पे शायद दिया नहीं होगा हमने.
हाँ, हम लोग नहीं दिए थे सर.
वो देखना पड़ेगा.
उसकी वजह से भी हो सकता है वॉल का. तो
ओके, हम लोग क्या करते हैं, जो है वो देख लेते हैं. एक्चुअली द साइज 230 बाई 900 ये शेयर वॉल का दिया था हमने.
साइज डेप्थ दिया था और ये विड्थ था. तो उसमें हम लोग ये बोलते क्या लोड कम्बिनेशन नहीं ना अप्लाई किए थे?
नहीं नहीं, लोड कॉम्बिनेशन जो है वही उसने लिया.
अच्छा, लेकिन
देख लेते हैं.
एक हाँ सर.
नहीं नहीं, ठीक है ना, देख लेते हैं अभी. लेट अस सी reports, or you can go to modify, or see after that for this failure you can click on modify, and in that you can go for modification of this. But let us see that reports first. So we'll go for reports design summary. Okay, or
Yes.
we'll go for text schedule. Let's say ductile schedule. अब जो फेल हुआ है उसका वो कोई नहीं देगा. बाकी दे देगा जनरेटिंग कॉलम टेक्स्ट शेड्यूल.
सर तो जो फेल हुआ उसका कुछ रीजन तो देगा? अच्छा
यस.
नहीं नहीं, कुछ वो नहीं देगा उसका.
हाँ, नहीं नहीं, वो जो फेल है उसका उसने डिजाइन किया ही नहीं ना. उसने रिमार्क रिमार्क दे के आपको बोल दिया कि अभी इस पर ध्यान दो बाबा, ये कुछ गड़बड़ हो रहा है. नाउ यू कैन सी ओवर हियर. This is text schedule. So and text schedule is in you can check it. This is for column 3. So only up to base to PL, and rest of the things is these are the things which are not defined. That means these are the failures that he is finding, and that's why he's not giving you that. And then again, these sections are okay. That's why he's giving you the results, and you can check it for all. Somewhere it is failing, somewhere that means something is actually going wrong. I will have to see that. Okay. Full height for BE, that is for shear wall, I think. All are 230 by 900, and this is also 230 by 900. Only that is given. Okay, that means we have to go for reports and let's say detailed drawing design summary. In design summary, he will give you the reasons for that. Okay. Again, for related to column, whatever combination that you are using is given over here. And now you can check it. So column wall. So this is again column 3 is considered as wall, and you can see 230 by 900, 230 by 900. So 1 to 2, 6 to 7, and 7 to 8. So in between, it is not giving you any results. So analysis case. So this is load case. So load case number 13, 12. So you will have to see that over here. So load case number 13, load case number 12. These are the load cases for uh, considered as design load cases. You can check it, P for that, MX, MY, percentage, interaction ratio, main reinforcement, and links. So this way you will get each and every detailing, right?
Yes, sir.
So you just have to go through that and change that. I think in ETAB, whatever we have done it just for. Actually, I was showing you for that codal provision, how you can avoid the torsion. And in that scenario, uh, we have given the things, and because of that, some codal provisions are not fulfilled, because 230 by 900 again it is uh, more than 4, and that's why he is considering now in your input, if you check that and make it uh, null and void, so then he will consider everything as a column. So shear wall will not considered as a shear wall. See, we have given the criteria that D by B, if it is exceeding by 4, then consider that vertical element as column. Now, अगर हमने वो uncheck किया, so then that criteria will not be considered, and every vertical member will be designed as a column, right? Hello.
Yes, sir.
Yeah. So you can do that also. Okay, then one more that go to reports, and in reports, design for all load combination calculation. Let us go for detailed drawing. So we'll go for all columns, and let's see that. So he's preparing that. Okay, now you can check it with this. See here, you can check that. So here he is considering this one as a boundary element.
Yes, sir.
As boundary element. So 230 by 425 is your one boundary element. 230 by 425 is another boundary element, and middle things are of the 1280 mm out of this 2130, and the requirement is 12 number of tot 20 plus 12 number of tot 10, and you can see that this type of reinforcement, that means these are the 10 diabars, and this
हमारा कॉलम साइज क्या था?
this is 230 by 2130. That was of the lift.
Okay, sir.
Hmm?
Yes, sir. Yes, sir.
Yeah, and now you can see B main link. So this is main link. Then mid type of main link, torret at 300. So
Spacing
B
300.
others. So these others, torret at 100, and this, and that also you can check it over here. See this RCDC is giving you a ties something like this. So, but these ties are considered as closed ties. You can see that entire. So one is going like this. and another is again going like this, and then this is one single, then little bit like this, and
Yes,
inside
sir.
that there will be one somewhere here. So you can check this. This is one. Where it is. This is one more. One more. Yes.
सर तो ये शेयर वाल का था, कॉलम पर जाइए, कॉलम का दिखा,
ये दिस इज
ये शेयर वाल है सर।
नहीं, ये 230 अगेन, ये सारे उसने वही लिए एक्चुअली। हम लोगों ने 230/900 ई टैब में कब दिए थे पता नहीं मुझे।
सर ये आपने शेयर वाल का ले लिया, हम आई थिंक मुझे याद है आपका 500 था, 500 mm
530 आई थिंक।
हाँ 230 into 500 है, 530 समथिंग।
शायद मैंने एमडीबी फाइल है ना दूसरा, मगर यही है ना अपना एमडीबी फाइल। Everywhere he is giving the same size. See, the software does not make any change. Yeah? So somewhere in the input, we have given instead of 600, we have given 900. That's why he is doing that. So actually, I have to see the ETAP file first, and then provide that as a MD, convert that to MDB file, because all this information is read by MDB file with the help of analysis report that has been defined created by ETAP file. So अगर check करना है, you will have to go to ETAP file, क्योंकि we are not giving any input.
बाय मिस्टेक सर ये फाइल आ गया, लेकिन ये था नहीं हम लोग के पास, ये फाइल आपने नहीं अच्छी किया।
यस, वो मैंने वो रेफरेंस में से जो लिया ना, that was not the file. Actually, we are having some another file, MDB
Yes,
file.
sir. Yes, sir.
So that's why he is not providing the result. But anyway, this is the process. Actually, the process is same. You can see the process is just create the file, go to settings, provide the proper
Okay.
settings, then go for design as a auto, and then you can go to reports, and then you can also go to BBS. So generate BBS. So he will provide the BBS, and here you can say all columns. Let's say all this as it is. So and generate. बाकी कुछ शायद मुझे भी थोड़ा प्रैक्टिस करना पड़ेगा अभी आपसे इसी का। नॉर्मली
होता है सर, बहुत दिन बाद अगर टच करते हैं तो ये होता है।
नहीं, एक्चुअली आई डोंट यूज आरसीडीसी इन माय ऑफिस, एंड इनफैक्ट मैं ऑफिस में किसी को बोलता हूँ आरसीडीसी का ये जो AutoCAD का ड्राइंग है ना, वो रेफरेंस के लिए ले लो, बट डू इट ऑन योर ओन, क्योंकि ETAP से ही रिजल्ट ले लो। वी आर हैविंग एक्सेल शीट्स. Actually, we are also giving you the demos for that Excel sheet, no?
Yes.
I think Anil sir is giving you
सर
that.
अभी कॉलम का नहीं, वो फुटिंग का डेमो, फुटिंग ये कॉलम और बीम का भी बाकी है, अभी क्लास हुआ नहीं उसका।
नहीं, वो थोड़ा एक्चुअली मेरा ये सोच था कि पहले वो सारे डेमो क्लियर कर जाएंगे
तो
और
थोड़ा
फिर आरसीडीसी में
आप बात कर लीजिएगा एक बार।
नहीं, थोड़ा टाइम का जो गड़बड़ हो रहा है उनका और मेरा, इसीलिए उन्होंने कहा कि आई विल गो विथ दैट एक्सेल ट्रेनिंग। कुछ नहीं, वो भी बहुत अच्छी तरह समझा दे। और मुझसे ज्यादा जानकारी है उनके पास. See, this is you can see that everywhere. See, this is how the lab is provided.
Yes, sir.
Actually, I just wanted to show you the labs. See, the labs are staggered. See, some labs are provided over here, some labs are provided over here.
Yes, sir.
Yeah. So accordingly, the labs are created. Now, actually, this is the practice that is to be done, but this is difficult to achieve at site. It's very easy to say that have a labs below the slab, or you can see the elevation number 3. See, top slab. So right from junction it is providing, but normally at mid height, uh, labs are staggered. Let me give you how practically it is carried out. See, if this is your slab level, this is your slab level. So at L by 4 from both ends, you are not having a lapse, and some some bars are considered like this. So let's say this is lap. Another bar is provided like this, and it is lapped like this. Let's say it is lapped over here. Then there may be another bar which might be lapped over here.
छोड़ी जाइए.
So the laps are staggered in this range, which is L by 2. This L by 4 and L by 4 over here, we are not providing any lapping. That is how in practice the things are carried. So see, this is not I think this type of activity, you can check it like this. So, and this is not considered. So laps in the joints, this is not considered. Okay.
Okay, sir.
Yeah. So then what I can let you know, I think it is more than enough for today. And in next session, we'll go for design of beams and then slabs. Again with the help of RCDC.
सर ये जब खत्म हो जाए एक प्रोजेक्ट पर आप मुझे एक
Yes.
प्रोजेक्ट पर काम करवाइए सर. ये आरसीडीसी जब खत्म हो जाए तो एक
हाँ.
हाई रेंज बिल्डिंग का प्रोजेक्ट लीजिए, चाहे कोई स्मॉल ही प्रोजेक्ट लीजिए, G+10 G+9 उस पर एक लाइव
नहीं
प्रोजेक्ट.
नहीं, वो G+18 का पूरा प्रैक्टिकल जो है ना, हम आपको पूरा डेटा देने वाले हैं. डोंट वरी अबाउट इट.
ओके सर.
ऐसा नहीं है कि हम लोग देने वाले, जितना आपको कमिट किया है ना उससे डबल देने की कोशिश है हमारी. तो कम से कम जितना कमिट किया है उतना तो 100% देंगे. क्लियर?
क्लियर सर.
तो डोंट वरी अबाउट इट. हो सकता है शायद हमें थोड़ा एक्सटेंड करना पड़ेगा कोर्स. दैट विल डू, बट विल नॉट एडजस्ट विथ क्वालिटी.
7 मंथ बहुत इनफ टाइम है सर, हो जाएगा उसके अंदर सारा.
नहीं, बाकी है ना, मेरा अकेले का नहीं है ना, बाकी लोगों का ही है ना. सो हो सकता है, बट ऑलवेज me as well as Anil sir, we are always trying to provide more than whatever we have promised. One more thing is that in your batch, Sulekha madam has asked for us for that flat slab and PT slab. तो उसका भी थोड़ा इंट्रोडक्शन हम लोग देने वाले हैं.
ओके सर.
Yes, any other query?
सर एक पूछना था
हाँ.
अभी जो कॉलम आरसीडीसी में अभी जो फेल दिखा रहा था तो उसे हमें फिर से ई टैब में जाके उसका डायमेंशन चेंज करना है
नहीं.
या
नहीं, you can change it in that modify. There was one more that modify step. In that modify, you can change, but I will suggest that better do it in ETAB. See, actually, today, actually, I have brought that some old file. Actually, that was not our file. So we'll go. I will check the file that we have created. That MDB file. Unfortunately, I might have chosen some older file, and that's why we were getting, because I don't remember that we have the font for 230 by 900 size of column. I think 230 by 530 and 230 by 450 was the
yes
size.
sir 450 and 550.
सर एक लेक्चर और ले लेते हैं इस पर, और क्या कॉलम पर.
या
if पॉसिबल हो तो सर एक लेक्चर और ले लेते हैं.
ले लेंगे.
संडे को ये.
नहीं सर ये भी होना चाहिए ना, फेल होने पे समझ भी आता है, हर समय पास होने पे भी
वही चीज आप ही के केतन बात को
करेंगे, डोंट वरी.
संडे को एक लेक्चर
ये भी पॉसिबिलिटी
लोग-
अच्छी है कि अगर फेल हुआ तो क्या करना चाहिए, ये भी आना चाहिए ना.
नहीं, एक्चुअली सी मैं आप लोगों को ये बोलूंगा कि जितने बार आप फेल होते हैं ना, उतने बार आपको खुश होना चाहिए, बिकॉज यू आर ऑन द राइट ट्रैक.
यस सर.
फेल कब होता है? जब आप सही रास्ते पर जाने की कोशिश करते हैं तभी फेल होते हैं ना. गलत रास्ते पे जाने की कोशिश करो, कभी फेल नहीं होते. So see, I don't know. My philosophy is that if you are failing, that means you are on a learning track, and that is a good sign. क्योंकि सफलता आदमी को एरोगेंट बनाती है. सफलता आदमी को कुछ नहीं सिखाती. सफलता से आदमी एरोगेंट बनता है, और फेल्योर से वो लर्निंग प्रोसेस में आता है. क्लियर है?
यस सर. सर और एक पूछना था, वो जो टेबल हमने जो बनाए थे और वो डिटेल ड्राइंग, सो वो जो टेबुलर फॉर्म में आता है तो वो डायरेक्ट ऑटोकैड में इंपोर्ट होता है क्या?
Yeah. That is actually in AutoCAD. You can save it in any form AutoCAD, and you can re-edit.
ओके सर.
Yeah, actually it's a AutoCAD drawing prepared by machine. Or see, and whenever machine is doing something, it goes on mechanical way, and वो दिखने में अच्छा नहीं दिखता. इतना ही है. But that is the most detailed drawing that a machine can create, and that is the best part of RCDC. अगर आप सजावटी में अगर ज्यादा भरोसा, मतलब ज्यादा भाव नहीं देते हैं ना, तो you will get most detailed drawing if you save it in AutoCAD. कैसे करेला देखो, करेला दिखने में बहुत अच्छा दिखता है, मगर
खाने में और स्वादिष्ट लगता है.
मगर खाने में जाओगे ना, तब पता चलता है कि तो जो अच्छा नहीं दिखता है ना, वो एक्चुअली उसका क्वालिटी बहुत अच्छा होता है, और जो दिखाई देता है ना बहुत बढ़िया, वो करेला होता है. एनीवे, कुछ क्वेरीज है तो पूछ लो, otherwise we'll conclude today's session, and we'll go with additional session. Don't worry about it.
सर मेल आईडी आप अपना.
हाँ, नहीं, अविनाश जी तुम्हारा मेल आईडी है मेरे पास.
आप मुझे
मैं भेज देता हूँ
व्हाट्सएप पर.
अभी.
आप फ्री हो 1 घंटे बाद सर?
अभी मैं खाना खा के आपको भेज दूंगा।
और वो प्रॉब्लम सॉल्व,
हाँ,
मेरा प्रॉब्लम है जो सर,
वो भेज देना ना मुझे।
ओके सर, तो मुझे आप बता भी दीजिएगा कहाँ पर गलती हुआ है।
हाँ हाँ, वो चेक करके मैं बताऊंगा ना, डोंट वरी अबाउट इट।
ओके सर।
या मैं दे देता हूँ, और एक तो पहले अभी ये फाइल भेज देता हूँ, और
हाँ,
और उसका ईटे फाइल बनाना शुरू कर दो,
ओके सर,
और बाकी लोगों को भी वो फाइल भेज देना।
मैं फॉरवर्ड कर दूंगा सारे लोगों को।
हाँ, चलेगा चलेगा, विल डू। ओके ओके, देन विद दिस विल कंक्लूड टुडे सेशन। यस,
ओके,
ओके, थैंक यू।
गुड नाइट
थैंक
सर।
यू सर, गुड नाइट सर।
बाय।